Let's talk about how we respond to stress. Our bodies respond to stress by activating both the parasympathetic and the sympathetic nervous systems. As you will recall, the parasympathetic nervous system is our rest and digest system, and the sympathetic nervous system covers our fight or flight responses. When you experience a sudden shock, you have increased heart rate and breathing, carried out by the sympathetic nervous system. You also have decreases in digestive activity, which is carried out by the parasympathetic nervous system. Your liver releases glucose that provides you energy. You may also have bodily sensations such as goose pimples and other muscle changes. When we experience a shock, the hypothalamus in the brain is in charge of the stress response. So the triggering of the stress response sets in motion activity in the pituitary gland and the adrenal medulla. The hypothalamus releases CRF, and the pituitary gland secretes ACTH. And this stimulates the adrenal glands to produce the hormone corticosteroid. Cortisol then enables the body to maintain a steady supply of blood sugar. Signals from the HPA axis lead to the release of multiple substances. Some of these are related to fast responses in the body, which are represented in the blue pathway in the figure. These substances are involved in the fast response, such as epinephrine, norepinephrine. There are other substances related to the slow and persistent response to stress. This is cortisol, and they are shown in the red pathways. There have been numerous studies about cortisol. It can be measured in the blood and even the saliva. High levels of cortisol have been related to suppression of the immune system. Over a long period of time, it can also be associated with damage to the hippocampus. When someone experiences a prolonged stress event, the hippocampus is particularly vulnerable to damage because it plays a role in regulating our response to stress. So as stress damages the hippocampus becomes less and less able to respond to the stressor. So over time, there is greater destruction of the hippocampus. Research with rats has shown that the age of an organism can predict their response to a stressor. It appears, as shown in this graph, that younger organisms recover from stress more rapidly than older organisms. Research with humans has shown that the reported level of stress for an individual actually predicts the number of colds that they might experience over a long period of time. So this suggests that psychological stress has an impact on our immune system, our immune function, our body's ability to fight off colds. Public health data with humans has also shown that there can be a dramatic increase in the number of cardiac deaths on days of the year in which there's a major stressful event, such as an earthquake. Research with children suggests that experiencing prolonged stress in childhood can lead to very damaging kinds of effects, leading into poorer functioning even in adulthood. So the poor hippocampal functioning, which affects memory, there may be hippocampal damage, reduced hippocampal volumes, and children may in fact suffer from these situations that affect their academic performance. To receive a diagnosis of post-traumatic stress disorder, or PTSD, one must have the symptoms occurring lasting more than a month after the particularly traumatic event. And the memories of the event do not fade. They typically intrude into consciousness unexpectedly during daily life. Some of the most common PTSD symptoms include hypervigilance, feeling that you're on alert all the time. You're easily startled. You have shortness of breath. You might have heart palpitations. You might have dizziness, excessive sweating, a disturbed sleep. You may be feeling tired a lot or fainting, have headaches, difficulty concentrating, be forgetful, and be irritable. PTSD symptoms have been observed after a variety of life experiences, including experiences in war, being tortured, sexual assault, physical assault, traffic accidents, natural disasters, life-threatening illnesses such as cancer. Also, even just witnessing or hearing about the assault of another person can give rise to PTSD symptoms. Today, the term PTSD is used in connection to military service and responses to terrible experiences in military service, in previous generations, different words were used. In the Civil War, it was called irritable heart syndrome. In World War I, it was called shell shock or effort syndrome. After World War II, it was called combat stress syndrome. It was only after the Vietnam War that the concept of PTSD began to arise. Studies have shown that about 70% of all people will at some point in their lives experience a trauma event, but not everyone who experiences trauma will go on to experience PTSD. Only about 20% of people exposed to trauma develop PTSD symptoms. And it's hard to do this research, in particular because there still is a stigma about admitting that you have PTSD symptoms. So we may have a situation where it's hard to estimate the true number of people having this. There's evidence from PET scans and MRI studies showing that the brains of individuals with PTSD differ from controls. Specifically, PET scans show that there's increased right amygdala activity when individuals are exposed to combat movies. MRI studies show that male combat vets and female survivors of childhood sexual abuse show reduced hippocampal volumes, suggesting that the stress experiences and PTSD experiences lead to a reduction or damage to the hippocampus. The good news is that PTSD does respond to treatment. Studies have shown that the effect size for psychotherapy alone is much larger than the effect size for medication alone. That's all for now.